Okay, now we're going to do question 5 on the paper, which is an integration question. And it looks as though it's an integration by inspection, the first part at least, because it's asking us, the first part is asking us to differentiate this. And the reason it looks like an inspection question is that if I can work out what the differentiation of this is, then whatever the differentiation is, I can integrate, and I should come back to that. And that's going to be a clue to how to do the next part. So let's work out what the differentiation of that is, because it's asking us to. And it's just to see one sort of differentiation. So we get 4x minus 8. And I'm going to rewrite that. I'm going to factorise this as 4x minus 2. Okay. And that's going to help us with the next part. So this was 5a. 1. And now for part 2, it says hence integrate. It's a hence. So we can use the fact that we know what the differentiation of this is to integrate this. And if you look at the denominator is what we had up here, and the numerator is x minus 2. Now when we differentiated the denominator, we got 4x minus 2. And when I'm trying to integrate some sort of fraction where the numerator is the differentiation of the denominator, it's going to be a ln. It's going to integrate to a ln, and then we're going to have a look at a coefficient to put in front of it. That's going to it's going to make it fit, going to make it work. So let's have a look. We're trying to integrate x minus 2 to x squared minus 8x plus 3 dx, and I know that it's going to be it's going to have the form of ln. We're going to put the modulus sign to x squared. It's going to be ln of everything on the bottom. But when I differentiate this ln to x squared minus 8x plus 3, what I end up with is going to be is going to be 4x minus 2 over 2x squared minus 8x plus 3. And we don't want the 4 there. The 4's not there. So to get rid of that 4, we're going to put a quarter there. You can check that by doing the differentiation of it using the chain rule. This quarter here is going to cancel with the 4 you get when you differentiate 2x squared minus 8x. And I'm going to put this in some square brackets because it's a definite integral, and we're integrating between 6 and 4. Okay, so we've done the integration, but we just still got to put in the 6 and the 4. So let's do that part next. So I'm going to take a quarter out, and it's going to be ln. I'm just reading this for 6. So this is going to be ln 2 times 6 squared. Well, that's going to be 72. Ln 72 minus 8 times 6. Well, 8 times 6 is 48, so that's minus 48 plus 3. And then we're going to take away ln, and we're going to put 4 in. So 4 squared is 16, so that's going to be 32. Take away 4 times 8. Well, 4 times 8 is going to be minus 32. And then we're going to add 3. Okay, and that's that. And there's a quarter here still. Everything gets multiplied by a quarter. So this is going to be 1 quarter ln 27. Take away ln 3. Okay. Let's just go back up and say, what does it want us to write it in? It wants the answer to be some number k, some multiplied by ln 3. So let's try and get everything in terms of ln 3. Well, this is going to be ln 3 cubed minus ln 3. And remember, look, I can take this 3, the power of 3, out to the front of the log. So this is going to be 1 quarter 3 ln 3 minus ln 3. And finally, we're going to get to 1 quarter times 2 ln 3. And finally, that's 2 over 4 which is going to be a half. So this is a half ln 3. Okay, so that's what the integration gets you to. So that was integration by inspection. And then we've got this substitution. Use the substitution u equals 3x minus 1 to find the value of this, given your answers in terms of x. So let me just write, let's start a new page. The substitution was 3x plus 1, I think. Yeah. Sorry, 3x minus 1. And we're trying to solve the integration of x and then the root multiplied by the root of 3x minus 1. So it's x 3, x minus 1 dx. Okay, so it's told us what the substitution is. Now, when we're doing substitutions, there's a few things that we might need. Firstly, you don't always need to find this, but you may as well. X is going to be u plus 1 over 3. So I'll rearrange so I can find out what x is. If I need to make a substitution over 3, I'm going to need to know, I'm going to have to get rid of this dx at some point, so I'm going to have to work out what that is. So to do that, I'm going to find du dx, which is just 3. So then I can, so dx is du over 3. Okay, and now I can use these things to substitute in. Now there's no limits on this integral, so it's an indefinite integral. So I'm just going to substitute change the x's up here to u's. So I'm going to keep that x there for the moment, but this 3x minus 1, the root of 3x minus 1, is now going to be just the root of u. And dx is going to be du over 3. So that's the integration I'm doing. So the x didn't cancel, so I am going to have to use this this thing here and sub that in for the x that I've got there. So this is going to be now u plus 1 over 3 times, I'm going to rewrite the u, the square root of u as u to the half, and it's du over 3. And let's just try and tidy this up a little bit. This is u plus 1 times u to the half, all over 9 du. I can take that 9 out, and this is going to be u to the 3 over 2 plus u to the half. And now this is something nice that we can differentiate. This is like a C2 differentiation. So it's going to give us 1/9. I'm going to keep that outside of all this. And so when we integrate, the power goes up and we divide by the new power, so it's going to be u to the 5 over 2. And then we divide by the new power. The new power is 5 over 2, so that means it's going to be 2 over 5, 2/5 like that. And then we're going to integrate this one. This one is going to go up to u to the 3 over 2. And we divide by 3 over 2, so that's going to be 2 over 3. Okay. Like that. So let's just try and just keep going with this, trying to keep it quite tidy. So this is going to be 2u to the 5 over 2 over 45. There should be obviously a plus c here, and plus 2u to the 3 over 2 over 27. There, I can take what I want to do is substitute the u is something that we came up with, so we've got to write the answer out in terms of x, and remember that x was 3x minus 1, so this becomes 2, So it's 3x minus 1 to the 5 over 2 over 45, I'll write that there, plus 2 over 27 plus 2 over 27 3x minus 1 to the 3 over 2 plus c, the integration constant, and this was all equal to the thing we were trying to integrate at the start, which was x 3x plus 1. Okay, and that's the final part of that.